So here are the solutions to the Unit 6 practice test you've just written right now. The first page is a cheat sheet of sorts. It gives you all the trig ratios. And in this first triangle right here, it shows you what the reference angle is, x, and what the opposite and adjacent would be if the reference angle was down here. Of course, the hypotenuse is always directly across from the 90-degree angle. Over here, we've moved the reference angle up to the top, thereby changing the opposite and adjacent sides. But the hypotenuse remains directly across from the 90-degree angle. Section A involved matching letters with a definition. So A, the side across from the angle under examination. Well, the angle under examination is just another way of saying the reference angle. So the side across from the reference angle is opposite. B, the side across from the 90-degree angle, is the hypotenuse. And C, the side next to the angle under examination, or the reference angle, but not the hypotenuse, is the adjacent, leaving, of course, trigonometry to be the branch of mathematics that deals with the measurement of the angles and sides in triangles. Here in this section, we have a number of multiple choice questions. Question 1 asks, what is the sine of 15 degrees? On our calculator, we simply go to sine, enter 15, enter, for an answer of 0.2588. Question 2 asks, what is the cosine of 32 degrees? Here we choose the cosine button, enter 32, hit enter or equals on your calculator for an answer of 0.8480. Question 3 asks for the tan of 46 degrees. Select the tan button, enter 46, equals 1.0355. If sine A equals 0.6561, then the angle A is approximately one of the following. So if the sine of A equals 0.6561, then A by itself equals the inverse sine of 0.6561. This is a very important pattern to get comfortable with. Once again, if the sine of an angle, such as A, equals 0.6561, then A by itself equals the inverse sine of 0.6561. So we're looking for the angle A, and we figured out that it is the inverse sine of 0.6561. So to get that inverse, we click on the second function button. Then our sine becomes an inverse sine. We simply enter 0.6561. Click enter, and we get a value of 41 degrees. Question 5 says, if the cosine of A equals 0.8988, then angle A is approximately. So once again, If the cosine of an angle equals 0.8988, then the angle itself, A, equals the inverse cosine of 0.8988. To calculate the inverse cosine of 0.8988, go to our second function mode, press cosine to bring up the inverse cosine, and type in 8988. Click enter to give us a value of 25.99, which will round up to 26. Question 6. In triangle XYZ, the measure of angle x to the nearest degree is one of the following. So, we're told that x is going to be our reference angle. So the first thing we need to do is label our sides relative to the reference angle. That makes our opposite side 17 and our adjacent side 12. The trig ratio that deals with opposites and adjacents is 10. So we can say that the tan of theta equals opposite over adjacent. For this specific triangle, we can say that the tan of theta equals 17 over 12. At this point, up to now, we take that 17 over 12 and convert it into a decimal, and then find the inverse tan of that. With your calculators, you can save yourself a little step, though. So in this case, I am going to press the second function, go to my inverse tan, and instead of typing in the decimal here, I'm just going to leave it as a fraction. 17 divided by 12, close the brackets, and that'll give me an answer of 54.78. So our answer is D, 55. We take the closest one, we round 54.78 degrees up to 55. The length of the indicated side to the nearest tenth of an inch is one of the following. So we're given a reference angle of 70 degrees. So if that's our reference angle, we can label the sides. We're asked for y, which is adjacent, and we're given the hypotenuse. So the trig ratio that deals with adjacents and hypotenuse is the cosine. So we can say that the cosine of 70 is equal to y over 15. We can rearrange that to say that y equals 15 times the cos of 70. Once again, instead of converting our cos 70 into a decimal and then multiplying it by 15, we'll let our calculator do the work for us. So we'll just enter cos 70, close the bracket, multiply it by 15, click enter to give us a value of 5.13, which in this case is letter D. Neil's toy boat has a base 50 centimeters long. The horizontal length of the sail is half the length of the base of the boat. The height of the sail is one of the following. So, if the sail is half the length of the boat, we can say that the base of the sail is 25 centimeters. Our reference angle is 50 degrees, and we're looking for the height. As always, we'll label our triangle relative to our reference angle. So we're asked to find the opposite side, and we're given the adjacent side. So the trig ratio that deals with opposites and adjacents is tangent. So we can say that tan of 50 equals x over 25. We'll use h instead of x from here on in. So h equals 25 times the tan of 50. So we have x equals 25 times the tan of 50. Put in tan 50. Close the bracket. Multiplied by 25. Giving us an answer of 29.79, which we can round up to 29.8. So our answer is letter A, 29.8. Calculate the measure of the unknown angles or unknown side in the triangles below using one of the trig ratios. Round your angle answers to the nearest full degree and length answers to 1 decimal place. So here in question A, x is our reference angle. So when we label them, that will make the 4 centimeter side the opposite and the 8 centimeter side the adjacent. So the trig ratio that deals with opposites and adjacents is the tan. So we can say the tan of x equals opposite or over adjacent. And in this case, tan of x equals 4 over 8. We're looking for an angle x. So when we're dealing with angles, we need to use the inverse tan. So we can say x is equal to the inverse tan of 4 over 8. Since we're looking for an angle, we'll have to use our inverse tangent ratio here. I just said that. So we'll click the second button, then tangent, which brings up our inverse tangent, and then in brackets, we'll put 4 divided by 8, close our bracket, for a value of 26.5 degrees, which will round up to 27. In this example, our reference angle is x, and we're given 2 sides. So since our reference angle is x, we can label our triangle with the opposite being 6.5 and the hypotenuse being 10. The trig ratio that deals with opposites and hypotenuse is the sine. So we can say that the sine of x equals opposite over hypotenuse, or in this case, the sine of x equals 6.5 over 10. We're looking for an angle, so we'll be using the inverse sine ratio. We can say x equals the inverse sine of 6.5 over 10. Now, because we're looking for an angle, we're looking for the inverse sine of 6.5 over 10. This guy keeps repeating himself. Using our shortcut, we'll go to the inverse sine and type in 6.5 divided by 10, close our bracket, enter, gives us a value of 40.54 degrees. Here we have a reference angle of 50 degrees, and we're looking to solve for side x. Relative to the 50-degree angle, here are our adjacent and hypotenuse sides. The trig ratio that deals with adjacent and hypotenuse is the cosine. So we can say the cosine of 50 equals adjacent over hypotenuse. Specifically for this triangle, we can say the cosine of 50 equals x over 25.1. X will therefore equal 25.1 times the value of the cosine 50. We need to calculate 25.1 times cos 50. So we'll start by putting in our cosine 50. Close our brackets. Multiply it by 25.1 to give us an answer of 16.13. Here we have a reference angle of 26 degrees, and we're asked to find side x. Relative to the 26-degree angle, x is the hypotenuse. Our opposite is 5 meters. So our trig ratio dealing with opposites and hypotenuse is the sine. So we can say the sine of 26 equals opposite over hypotenuse. The sine of 26 equals 5 over x. Sine 26x equals 5. X equals 5 divided by sine 26. To solve 5 over sine 26, we type in a 5 divided by sine 26. Press enter, and we come up with a value of 11.4. Triangle PQR. PQ is 50 centimeters long, and angle Q is 48 degrees. Determine the length of RP to the nearest tenth of a centimeter. So I've labeled the side RP as X relative to our reference angle, 48 degrees. X is the opposite, and 50 is the hypotenuse. The trig ratio that deals with opposites and hypotenuse is the sine. So we can say the sine of 48 equals opposite over hypotenuse. Specifically, we can say the sine of 48 equals x over 50. X, therefore, will equal 50 times the sine of 48. We're looking for the value of 50 times sine 48. So we put in sine 48, close our brackets, multiply by 50, and gives us a value of 37.15, rounded up to 37.2. In this word problem, I've redrawn the word problem with a bigger triangle. It's just a little bit easier for us to represent everything. So we have a reference angle of theta, and two sides are given. So we'll label our triangle relative to the reference angle. So our adjacent is 2.0, and our hypotenuse is 2.6. The trig ratio that deals with adjacents and hypotenuse is the cosine. We can say the cosine of theta equals adjacent over hypotenuse. Or for this triangle, we can say the cosine of theta equals 2 over 2.6. Rearranging it algebraically, we can say 2.6 times the cos of theta equals 2. The cosine of theta equals 2 over 2.6. And theta equals the inverse cosine of 2 over 2.6. With our calculator, we want to solve for the inverse cosine of 2 over 2.6. So we use our second function button. Click on cosine. 2 divided by 2.6, close our bracket, for a value of 39.71. And this rounds up to 40 degrees. Question 2 here. A ship is 565 meters away from a lighthouse. The angle between the line formed by the front of the ship to the top of the lighthouse and the water is 4 degrees. Calculate the height of the lighthouse above sea level, rounded to 1 decimal place. Assume the lighthouse makes a 90-degree angle with the water. Well, we can simplify this situation just by drawing a triangle. So there's a reference angle of 4 degrees. We're 565 meters away from the base of the lighthouse. We want to know the height of the lighthouse, so that'll be x. So x is opposite our reference angle, and 565 adjacent to our reference angle. Our trig ratios that deal with opposites and adjacents are tangents. So we can say the tangent of 4 equals opposite over adjacent. In this case, the tangent of 4 equals x over 565. Therefore, x equals 565 times the tangent of 4. So we're being asked to solve 565 times tan 4. Go to tan. Type in 4, close the bracket, multiply by 565, giving us an answer of 39.5. Therefore, our lighthouse is 39.5 meters high. Murray and Samia are facing each other on opposite sides of a 15-meter flagpole. From Murray's point of view, the top of the flagpole is at an angle of 50 degrees. From Samia's point of view, the top of the flagpole is at an angle of 30 degrees. How far apart are Murray and Samia from each other? So I've represented this situation with a bigger triangle at the bottom there. 50-degree angle from Murray, 30-degree angle from Samia. I find it easier, though, to think of it as 2 different triangles. So we'll split them apart like this, and we'll label them relative to the reference angle. So there's the opposite of 15 and the adjacent of x. We're trying to find the distance of Murray from Samia, so we're trying to find what the x and y values are. These represent the distance that both of them are from the flagpole. There's the labels for Samia's triangle. Let's give them numbers just to keep track of what triangle we're dealing with. And we'll put our equations up here. So, relative to 50 degrees, we're given the opposite and asked for the adjacent. The trig ratio that deals with opposites and adjacents is the tangent. So we can say that the tangent of 50 degrees equals 15 over x. For Samya's triangle, or triangle 2, we can say that the tangent of 30 degrees equals 15 over y. Going back to triangle 1, we can say that tan 50x equals 15, and for triangle 2, we can say tan 30y equals 15. X equals 15 over tan 50 for triangle 1, and y equals 15 over tan 30 for triangle 2. So here we have two equations to solve. The first is 15 over tan 50. 15 divided by tan 50 gives us 12.58. And the second one is 15 divided by tan 30, which gives us 25.98. We'll round up to 26. So now we have two distances for these two people. Murray is 12.6 meters from the flagpole, and Samya is 26 meters from the flagpole. Therefore, if we add these two up together, we can find out how far Murray and Samya are from each other, which happens to be 38.3 meters apart.